In this video, I'm going to go through some examples about radicals. The first example wants us to convert 5 times the square root of 4 into something in the form the square root of a, where a is an integer. Here we can say that 5 is equal to the square root of 25. Then we can replace our expression with the square root of 25 times the square root of 4, and that can just become the square root of 25 times 4, or the square root of 100. Note that what we just did here is the opposite of converting a number into simplest radical form, because we could have started with the square root of 100, and to convert it to simplest radical form, we would have ended up with 5 times the square root of 4. This example is just about multiplying radical expressions. We can begin by rearranging what we have. We can group the 2 and the 5 together, and then the square root of 18a cubed and the square root of 72a squared b cubed. Then 2 times 5 evaluates to 10, and then we have the square root of 18 times 72 times a cubed times a squared times b cubed under our radical. At this point, if I don't want to actually calculate 18 times 72, I can use a trick. I can rewrite 18 as 2 times 9 and 72 as 8 times 9. And then we can rewrite that as 16 times 9. We can do something similar with the variables. So a cubed times a squared, we can rewrite that as a to the 4th times a. And similarly, b cubed is b squared times b. And now we can rearrange some things, and we end up with 10 times the square root of 16 times 9 times a to the 4th times b squared times ab. And at this point, we can see that all of these terms here are perfect squares. So we can bring them out from under the radical, giving us 10 times 4 times 3 times a squared times b, and then we keep the ab here. And so that just simplifies to 120 a squared b times the square root of ab. Here we're multiplying two radical expressions. Recall that when we have two binomials that we're multiplying against each other, we can use something called FOIL. FOIL stands for first, outer, inner, and last. So our first terms are a times the square root of 5 and b times the square root of 3. So we can write that as ab times the square root of 5 times 3, or ab times the square root of 15. Our outer terms are a times the square root of 5 and c. So that gives us ac times the square root of 5. Inner terms, we have minus 3 square root of b and b times the square root of 3. So that gives us minus 3b times the square root of 3b. And our last terms, minus 3 square root of b and c. So that's minus 3c times the square root of b. And our answer is just all of these added up together, or ab square root of 15 plus ac square root of 5 minus 3b square root of 3b minus 3c square root of b. Here we're going to get some practice with rationalizing the denominator. In all of these examples, the trick is to figure out what to multiply the denominator by so that it's no longer a radical. So for our first one, we can multiply by the square root of m. And if we do that to the denominator, we have to do the same thing to the numerator. So our answer becomes 4 times the square root of m over the square root of m times the square root of m, which is just m. In the second example, we're taking the cube root of m. So instead of multiplying the numerator and denominator by the square root of m, we can multiply them by the square root of m squared. This way, in the denominator, we end up with the cube root of m times m squared, or the cube root of m cubed, which is just m. And then on top, we have nm times the square root of m squared, which is just equal to m. Our m's cancel out, and we get as our final answer n times m. In this last example, we're taking the fourth root of y plus 2 all cubed. We can multiply the denominator by the fourth root of y plus 2. And this way, we end up with just y plus 2 in our denominator. So we have to do the same thing to the numerator, multiply by the fourth root of y plus 2. And so we end up with 5y times the fourth root of y plus 2 in our numerator. For this last example, we're going to be multiplying both by 1 plus the square root of y. So in our numerator, we're going to have to use FOIL. That means that we'll have first, outer, inner, and our last terms multiplied together. And then this last term is just equal to 3y. We can combine that with the first term, 4y, and that just gives us 7y plus 4y times the square root of y plus 3 times the square root of y. Now in our denominator, we use the difference of squares formula, and we get 1 squared minus the square root of y squared, or just 1 minus y. So that means that we have as our final answer 7y plus 4y times the square root of y plus 3 times the square root of y over 1 minus y.